So today we're going to work on 45, 45, 90s. There's two types of special right triangles. One's the 45, 45, 90, which is the first slide, and then the second slide is the 30, 60, 90s. We are not doing the 30, 60, 90s today. That is something we will do next time we meet. But right now, 45, 45, 90s, what makes them special, again, these are right triangles. They have to be right triangles, okay? One of the other angles is 45 and the other one is 45. You're going to notice that all of these this particular triangle is going to be isosceles. So these two sides are going to be congruent. Their base angles are congruent. What you really need to take a look at is those sides. So the two legs are always x, and the hypotenuse is always x root 2. It's always x root 2. Okay? Yeah, and you need to memorize it. Okay? Again, because the ACTs, they do not give this to you. Those special ed tests, they just don't. So when you are doing these triangles, and it looks like that, I'm going to make sure that you put the formulas inside the triangles. Okay? That's the key. So as soon as you get these triangles, what you're going to do is inside, I'm going to make this as small as I can. This is going to be x, this is going to be x, and this is going to be x root 2. You always put the formula in the triangle. Inside, do not put it outside. Why? You're going to find out when it starts getting kind of difficult that this is the best way of handling it. Okay? And I don't want some kids to go, well, I don't need to do that. I'm not going to say, yeah, you have to do it and you don't have to do it. I want everyone to do it, okay? Because it does get kind of tricky for a while. So you're going to notice that x is 3, okay? So if x is 3, then I know this side is 3, right? And since x is 3 on this side, this ends up being 3 root 2. See that? So all I did was take out the x and I put in the 3. That triangle's done. Okay, so some of them are really, really easy like that. Okay, now let's move on to this one. Again, I'm going to go x, x, x root 2. Okay, now you're going to notice that this side is 6 root 2. Do you see that? Okay, do you see this right here? This is my x. Do you see this out front? Okay, because I know that x is what? X is going to be 6. I'm going to come up here and I'm going to go, okay, this is 6 then, and this is 6. So sometimes it's really easy. You can just take a look at it and know immediately what x is and just fill in those values. Okay. Questions on those two? You can be like, seriously, you think this is hard? These are easy, okay? They get a little bit more complicated. All right, here's this one now. Again, this is x, this is x, this is x root 2. Okay. Do you see how this just became more complicated? This is not 9 root 2. So we need to solve for x. So we're going to be using some algebra on this. So what I'm going to do is I'm going to come down here and I'm going to write x root 2 equals 9. Right? Now what operation is between the x and the root 2? Multiplication. How do I undo it? I'm going to divide. So I'm going to divide both sides by root 2. Okay, and what that does is it cancels these root 2's. So I end up with x equals 9 over root 2. Now, in math, we don't have square roots on the bottom. We don't have it in the denominator. That's a bad thing, okay? It's kind of like dividing by a fraction. It's just not a good thing to do. And so you need to do something that's called rationalization, okay? So I'm going to come off to the side and I'm going to write what it is. It's called rationalization or rationalize, okay? That's what this is. And to do that, what you're going to do is you're going to multiply by root 2 over root 2. And you can go, well, why root 2? Because the denominator is root 2. If it was root 3, you'd be multiplying by root 3 over root 3. If it was root 5, you would multiply by root 5 over root 5. Okay, and you're going to see this a lot. So you got to make sure that you remember how to do this. Okay. So what this does then is I multiply across and I get x equals, if I multiply across, these two come together and I get 9 root 2. Okay, and root 2 times root 2 is, it's 2. Remember when we had root 2 and we squared it yesterday? Yeah, so it's over 2. Now this can be reduced more. And so I'm going to make this x equals 9 divided by 2 is 4.5 root 2. And this is my answer. Sometimes they leave it as 9 root 2 over 2. If you can make it into a nice neat fraction or decimal, go ahead and do that. If not, if it's like 2 root 2 over 3, like this, if it's like 2 root 2 over 3, something like that, you're going to leave it like this, okay? Notice that I did not do anything with this, okay? Notice that the root 2 is inside the house and it doesn't come outside, okay? It's a prime number. We're going to leave it inside, okay? Let's do another one, right? So this is x, this is x, this is x root 2. Okay, so I know that x is 13 root 2. I'm going to come over here and I'm going to go 13 root 2 because that's my x. Okay, now this is special, isn't it? That's going to be a little bit different. So what I'm going to do is bring it down here and I'm going to go x root 2. And I'm going to fill it in. I know that this x is 13 root 2. So I'm going to write 13 root 2 times root 2. Okay. So I'm going to leave this as 13, and root 2 times root 2 is 2. So I end up with 26. So this over here then is 26. Okay. Questions? If you put that in your calculator as 13 root 2 and then multiply it by root 2, you would get 26. But the more you see the commonalities and see how root 2 times root 2 becomes 2, and you can do it in your head, the quicker you're going to be, and that's going to help you on your ACT. Okay. Questions on that? All right, that's all I got for you today, and we'll move on to the 30, 60, 90s the next time we meet.